Find the exact value of each expression if it is defined. Sine inverse of 1, cosine inverse of 0, tangent inverse of root 3, and sine inverse of negative root 2 over 2. Assuming that each of these has an answer, we will let that answer be theta, because the result of an inverse trigonometric function is an angle. We don't know what it is, so we call it theta for now. The reason why we want to set it equal to theta is because we want to rewrite it without using inverse notation. Sine inverse of 1 equals theta can mean only one thing, and that is sine of theta equals 1, assuming that theta is an angle between negative pi over 2 to pi over 2. Now, we look at the unit circle and find out which angle theta whose sine of theta equals 1. And there is only one theta that will give us this value of sine theta, and that theta is pi over 2. Pi over 2 is an angle in this restricted domain, so the answer is pi over 2. Sine inverse of 1 equals pi over 2, and that is our answer. Similarly, we will let cosine inverse of 0 equals to theta and rewrite this as cosine of theta equals 0, where this angle theta is in the restricted domain 0 to pi. We then look at the unit circle to see where it is that cosine of the angle equals 0, and that angle has to be pi over 2. Pi over 2 is in this restricted domain, and so we conclude that cosine inverse of 0 equals pi over 2. Tangent inverse of root 3, we let it equal to theta and rewrite this as tangent of theta equals root 3. The trick with tangent is that we set it as a ratio. Root 3 is the same as root 3 over 1, and then we would divide it by 2 in both numerator and denominators. Notice that this complicated expression is simply root 3. And the reason why we want to do this is because tangent is defined to be the y-coordinate over the x-coordinate. Keep in mind that for tangent inverse, this angle has to be between negative pi over 2 and pi over 2 exclusive. We then look at the unit circle to see where it is that we have the point x equals 1/2, y equals root 3 over 2. And within this interval, or in the first and the fourth quadrant, in this case, both x and y are positive, and so this angle is in the first quadrant. In the first quadrant, there will be only one angle whose terminal point is x equals 1/2, y equals root 3 over 2, and that angle is pi over 3. And so we conclude that tangent inverse of root 3 equals pi over 3. And lastly, sine inverse of negative root 2 over 2, we don't know what it is, so that we set it equal to theta. We rewrite this as sine of theta equals negative root 2 over 2. And again, this theta has to be an angle in the restricted domain for sine, which is negative pi over 2, pi over 2 inclusive. We then again use the unit circle and figure out which angle theta that will give us sine of theta equals negative root 2 over 2. Sine of theta is only negative in the third and the fourth quadrant, but we are looking for an angle in the restricted domain, which is only in the first and the fourth quadrant. And so the angle that we're looking for must be in this fourth quadrant. That angle has to be negative pi over 4, because sine of negative pi over 4 equals negative root 2 over 2. we conclude that sine inverse of negative root 2 over 2 is negative pi over 4.